All right. As promised, this is the forthcoming section, section 3.5, Writing Equation of Lines, Part 2. So let's recap sort of what we've done so far. What we've done so far is we've learned to write the equation of a line if we're given a point and a slope. This lesson, we're going to see how to write the equation of a line if we're given no slope and 2 points. So before we had a point and a slope, now we have no slope and 2 points. So we have a slightly different problem, but we're gonna try to approach it and see how we can work this out. So one of the things we did was we went from a graph on the left to the equation on the right. So we have a slope of 2m and a point 4, 5. So the equation of a line with a slope 2 and a point 4, 5, and we use the point slope formula. What did we do? Well, we rewrote the formula. We filled in the x1, the y1, and the m. We distributed, and we got y by itself. So those are our basic 4 steps, right? Our 4 steps: write the formula, fill in the x1, the y1, and the m, distribute on the right side, and get y by itself. Those are our 4 steps. So in the previous slide, I sort of elaborated on this. This was in section 3.5, the first one. I elaborated on this and kind of put some details. This is breaking it down to its simplest form. Write the formula, fill in the parts you're supposed to fill in, distribute, which means multiply, and then get y by itself. That's what you're trying to do. So the final answer is in slope-intercept form, so we're good. All right, today, what I'm going to look at and go over is this. We're going to write an equation of a line from 2 points. Now remember that when we write the equation of a line, we use something called the point-slope formula, which would seem to indicate that we would need to have 2 things, a point and a slope. In this case, look at the graph. I see a point. I see another point. What I don't see is a slope. Therefore, we can't use point-slope formula just quite yet, because in order to use point-slope formula, we need a point and a slope. We don't have a slope. So we have a problem. So here's the main problem. We need to use the point-slope formula, but that would imply we need 2 things, a point and a slope. We have in the graph 2 points, but we don't have a slope, so what do we do? Is the question. So here's the basic solution that we come up with. In algebra, the most basic thing that we're doing, and this is a basic skill that we're learning, and you know, and you kind of know this already. Probably throughout your life, you've had to do this. So you've done this before. What we do is we use what we know to find out what we don't know. That's basically what algebra is. We just do it with math symbols. It's we have knowns and we have unknowns. So we use what we know to find out what we don't know. What we know is we know 2 points. We also know there's a formula for slope that uses 2 points. So remember, m stands for slope. So let's go back and do a little bit of review. There's I think it's section 3.4 where I go over slope. And we're going to find the slope of a line that passes the point 1, 4, and 3, 8. So first note, make sure you write out the slope formula. The way we learn formulas in math is by writing them out over and over and over and over again. That's how we learn formulas in math. If you're saying, how do you know all these formulas in math? Because I've had to write them thousands of times. That's how I know them. It's not because I'm sort of like inherently smarter. It's because I've had to write this over and over and over again. The same way you have to memorize the social security number or some other kind of number, student ID or whatever. The way you know these numbers, your phone number even. Like how do you know your phone number to get to your caller ID, to get to your voicemail, sorry. You type your number over and over again. That's how you know what your phone number is, you know. It's just something you type over and over again. In the same way, the way that we know formulas, like slope formula, is we write the same formula over and over again. So we label our points, x1, y1, x2, y2. Notice we label it the same way every time, x1, y1, x2, y2. Now that they're labeled, we fill in the points, so y2 is 8, y1 is 4, x2 is 3, x1 is 1. Again, how do I know that? I label my points. I don't have to work that hard. I just labeled them and say, well, y2 is 8. How do I know that? Because I put a y2 underneath 8. Then we do the top. X minus 4 is 4. We do the bottom. 3 minus 1 is 2. 4 divided by 2 is 2. Go to my calculator. I get m equals 2. All right. That's the slope example number 1. Slope example number 2. So I want to find the slope of the line that passes through the points -2, -3, and 3, 7. So same process, x1, y1, x2, y2. Notice that when I plug in my formula, so y2 is 7, y1 is -3, I get 7 minus -3. But that's confusing. I don't want to have to deal with minus negatives. So what I'm going to do is use the fact that 2 negatives make a positive, and I'm going to change both of these minus negatives that I get when I plug in stuff. Again, this negative came from that -2, that minus is there in the formula itself. So we maintain that. We don't replace it or change it out. We keep it in the formula itself. That minus negative becomes a plus. All right. And then we go across the top. So this minus negative becomes a plus. 7 plus 3 is 10. This minus negative becomes plus. 3 plus 2 is 5. 10 divided by 5 is 2. All right. Slope example number 3. Same thing. We write the slope formula. We label our points, x1, y1, x2, y2. We have a minus negative on the bottom of the fractions. You see we have a minus negative on the bottom of the fraction, a minus negative. What do we do when we see a minus negative? We turn it into a plus. Now notice several things here. Number 1, this negative right here didn't change. It's not next to a minus. It's over there kind of by itself doing its own thing. This minus negative is right next, this negative is right next to a minus. It becomes a plus, but this negative here just sort of is minding its own business over here by the 7. It doesn't get changed. I want you to also notice at the top of the fraction, I have a minus and a negative, don't I? Isn't that a minus negative? No, not really, no. This minus and that negative are on top. They're on the same top of the fraction, but they are separated, not next to each other. We only change them to positives when they are right next to each other in each other's space. So this minus and that negative are right next to each other in each other's space, therefore they become positives. This minus and that negative are separated by a 20. This negative is chilling out on its own over here by the 7, not bothering anybody. The only time that we change these to pluses is when we have a minus and a negative that are right next to each other. And so that's when we change to positives. So none of the other negative numbers, none of the other negatives and minuses will change, only these two will change. All right, so just keep that in mind when you're doing it. All right, so I have -20 minus 8, goes to my calculator, give me -28. -7 plus 10, goes in my calculator, gives me positive 3. I get negative 28 over 3, which is a fraction. That's fine. If you make it into a decimal, you start rounding, you lose accuracy. It's a whole deal. We don't really want to do that. So we just keep it as a fraction because we like fractions are fine. I mean, they're fine. Okay. We have done 3 examples of finding slope. So now we can do what we need to do. Since we know how to get a slope from 2 points, we can use the 2 points we have, this 2, 9 and this 1, 5, to find the slope. Once we find the slope, we can then use the point slope formula, right? Because our whole problem was we didn't have a slope. Now we'll be able to find a slope, so we'll be good. All right. These are the basic steps. You label your points, you find the slope, you write the slope on one of the points, and then you go through the point slope formula. You go through the point slope formula thing, which we'll this is sort of like the comprehensive list of things. I'll go through a problem and I'll show you that it's pretty simple. But that's kind of a comprehensive thing if you just ever get lost and you're like, well, what's my next step? These are your steps right here. All right. So let's take an example. I want to write the equation of a line from 2 points. So the big $1 million question is, what is the equation of this line? Well, we can figure this out using 2 points. All right. So first thing we do is we identify what the 2 points are. So we say the first point, let's say this will be our first point, is 2 over 1, 2, 3, 4, 5 up. So 2 over and 5 up is 2, 5. The next point is 1, 2, 3 from the origin, right? If I start at the origin, I go 1, 2, 3. And if I start there and I go up, sorry about that, 1, 2, 3, I go 1, 2. So it's 3, 2. The 2 points in the graph are 2, 5, and 3, 2. So I'll break this into 2 steps. Step number 1, essentially. First, find the slope. How do you find the slope? Well, you go through the same steps. You label the points, you find the slope. So we have x1, y1, x2, y2. 2, 5, 3, 2. We have a slope. The slope is y2 minus y1 over x2 minus x1. That's the slope formula. Then we go through and we replace everything. So y2 gets replaced with 2, y1 gets replaced with 5, x2 gets replaced with 3, and x1 gets replaced with 2. Notice they basically want to be in the exact same spots as their original there because they're substituting it out. All right. So we get 2 minus 5 equals negative 3. 3 minus 2 equals 1. We get negative 3 over 1 gives negative 3. So the slope, m, is negative 3. So we first find the slope. Second, and this is going to be the longer bit, use the point slope formula. So now we have the slope. That means we can now use point slope. So we go through the steps. Number 1, write the formula. Y minus y1 equals m times x minus x1. Step 2, fill in the x1, the y1, and the m. So x1, y1, and m. We fill them in. Third, we distribute on the right side. We multiply. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. Then we get y by itself by adding or subtracting. To decide that, we basically say, what will cancel stuff out? I have a minus 5 on this side. The opposite of minus 5 is plus 5. Therefore, if I plus 5 on that side, it will cancel out the minus 5. So I get negative 3x plus 6 and I add 5 to both sides, this will cancel. 6 plus 5 is 11. So now y is by itself. I'm happy. We have the final answer. Y is equal to negative 3x plus 11. Right? So if we go back to the graph that we were looking at with 2, 5, and 3, 2, well, we say, what's the graph of this line? Well, we have the points were 2, 5, and 3, 2, and the graph of that line, the equation of that line is y equals negative 3x plus 11, which we have right here as well. All right, this slide has the same basic thing. Instead of breaking it into 2 parts, I went ahead and just made it one. I showed that that's all the work as one thing. So if you want to look at it all as one single thing, that's what you do. So again, it's a lot of steps, but if you memorize basically the 4 steps for the point slope formula, that's the hardest part. Finding the slope is actually the easiest part because all you're doing is plugging into a formula and making sure to deal with minus negatives and such, but you're basically just plugging into a formula. So yeah, just don't overthink that part of it, the slope part. All right. So to summarize again, our final answer is the slope-intercept form, y equals negative 3x plus 11. Remember, we first find the slope, then we use the point slope formula. All right, second example, writing a line from points. All right, we have a picture of a line, but we want to know what the equation of that line is. To figure this out, sorry, this should be a question. Why is that a question? We can figure this out using 2 points on the line. It's not a question. But the point on the graph are 1, 4, so 1, 4, and 6, negative 6. So that should be you should be able to identify what the points on the line are. If not, go back to 3, 1. Go through your 3, 1 homework. That should be something that you should be able to do, is identify what the points on the line are without knowing anything else. All right. So again, it's the same process. First, we find the slope because we need to use point slope, because that's how you find the equation of a line. Is you have to use point slope. We got to find the slope first. So we label our points: x1, y1, x2, y2, and then you get negative 6 minus 4, 6 minus 1, right? y2 minus y1, x2 minus x1. We label our points so we don't have to think about what those things mean. We just have to know that we have to just put them in the formula where they go. y2 is negative 6, it goes first. Minus y1 is 4. So if we just label our points, we don't have to think necessarily about what the points mean. We just have to plug them in. All right. So we get a slope of negative 2. Now we have the slope. That means we can now use point slope. So we go through our same steps. We write the formula like so. We fill in x1, y1, and m. We distribute, which means multiply. On the right side of the equation, we make sure and use all of our rules. Negative times negative is a positive. Negative times a positive is a negative. All the rules we have from before, and I'll put a slide up. I'll put up another PowerPoint to kind of go through those, because I think that's going to be something that's we need to remember. Yeah. All right. And then you distribute and you get y by itself. And as you can see, it's the same basic process. We find a slope, which is m, then we use point slope. So in summary, our final answer is in slope-intercept form. Y equals negative 2x plus 6, the line that passes through the points 1, 4, and 6, negative 6. Remember, we first we find the slope, because in order to use point slope, we have to find the slope. We have 2 points. We know how to find the slope from 2 points. So we label our points, we use the formula, we find the slope. Then we use the point slope formula, which is comprised of 4 steps. So that is basically what we do. Let's see, is there anything else? Yes. Section summary. 2 basic steps. Find the slope. Step number 1. Step number 2, use a point slope. That's what you're doing. The details of that are the tricky part, but that's basically that's the overall big picture, what you're trying to do. Find the slope, use the point slope. This is how we find the equation of a line. Tips. Remember to turn a minus negative into a positive. So if you see a minus negative, turn it into a positive. There's a slide on here that's a little more tricky. You have to kind of think about what that means. I think it's example number 3 in finding slope. You have to be careful, because you can't just say, well, I see a bunch of negative minus everywhere, I can turn them all into positives. You can't. You can't just read minus negative you see just everywhere, just in around, into a positive. There's a very specific, the minus and the negative have to be right next to each other. Right next to each other, neighbors. Not near neighbors, neighbors. Like right next to each other in each other's space. That's when you turn it into a positive. So remember, we turn minus negatives into positives. Remember to check your signs. It's going to be really important and imperative that you check all your signs. If you leave off a negative number or you accidentally put one on, it will change your entire answer and you'll miss the question. And you will have done everything else correctly, but because you didn't check your signs and you wind up leaving off a negative or putting one on, it's going to make everything different. And so it's important to check your signs. All right. And last but not least, practice, practice, practice. It is of singular importance that you practice the heck out of these things until you understand them and you get them. If you go through an assignment and you don't quite understand what you did, go back and review the assignment. I'm dead serious. You finished, even if you finish all the homework, go back and review it. If you don't know how to review it, let me know and we can figure out how to do that. We'll walk through it. Go back and do it again. Being able to work a problem once doesn't mean you know how to do it. Being able to work a problem twice doesn't mean you know how to do it. Being able to work a problem 3 times doesn't mean you know how to do it. Being able to work a problem 1,000 times means you actually do know how to do it. So it's about practice. It's about making sure that you retain it and that you know how to do it, not just the first time, not just the second time, but the 199th time. If you can do it the 200th time, then you know how to do the problems. So even if you finish all the homework in a section, go back and I will definitely put up reviews and stuff to kind of sort of assess where some of the problems are. But it's really important that you really know how to work a problem, because you've got to practice the heck out of these things. That's how you get good at it. It's not magic. It's just a lot of effort. And it's more effort for some people than it is for others. For some people, it's super easy. For some people, it's super hard. And that's just the deal. I can't make it easier for you or harder for you, really. Everybody's different. Everybody has a different kind of brain, and everyone has a different kind of proficiency for these things. But really, I think if anybody who wants to do this practices, the amount of times that they need to practice, not their neighbor, but they need to practice, you can get it. So don't worry if it takes you a long time. If it takes you a long time, that's you. That's how it works. I am not good at certain things. You might not be good at certain things. That's okay. You're you, I'm me, we're different. That's just how it works. So practice, practice, practice as many times you need to. And other than that, do I have another slide on here? I don't. Okay. All right. I think that's all.